Next, we're going to continue with what we left off yesterday. Okay, so what did we leave off yesterday? We have graphed log base 2x, right? We have graphed it. Shall we summarize? Domain, range, right? So I'm going to bring this to the top. I want you guys to bring your summary with you. Bring your summary with you. Okay, so that's enough. Summarize. Okay, so this is what we left off. Okay, summary on the function. Okay, we already called it the inverse because we have to go back there, right? And I'm going to put 175% for fun so that you can see the negative sign here. So what about the summary? Right? The function, domain, range, right? So this is the function. What is the rule of the function, right? The rule of the function. The rule of the function is x serve as a rule. And it produces output. Right? And what is the domain? Range, intercepts. What have you? Intercept. Yeah. X-intercept, Y-intercept. What is the domain?
The domain should be x is greater than 0, right?
Perfect. Perfect. If you have graphed the picture, right? If you have graphed the picture, you have gone through this process, right? You have plotted these points. You will never get the domain wrong. However, in the past, I see a lot of students get the domain wrong. Right? What's the range? That's something we didn't talk about yesterday, right? What is the range? And the range is it's also, I have come to think about it, I would say the range is actually a little bit difficult to understand. The range is a little bit difficult to understand, right? You see, yesterday we plotted the points, right? We chose our input, right? So these are inputs. All of these are inputs, the inputs, and here's our outputs. Inputs, outputs, all of these are outputs. And today we have seen the output can be -½ Then the output can be, you just saw that, the first question on homework, right? The output can be -½ So the output can be negative. The output can be 0. The output can be positive. So what can you say about the range?
We have one answer in the chat, Professor.
Is the range all real numbers? Perfect. That's it. That's what I want you to see. That's what I want you to see. right? You see, you do these simple things, right? We did these simple things and we observe and we generalize and we summarize. But I just only wish that the answer is given with more confidence. Confidence. So Wilbur, can you retype? Instead of not using question, but using a different sentence. Could you do me a favor? That's right. With confidence. With confidence. Give yourself a pat on the back. That's what I want you to see. You guys see that? I have to recognize that as a teacher, sometimes I overlook the fact that some of these things may be a little bit difficult to understand because domain is a positive number, but the range is all real number. Then you might be thinking, it seems that there are more real numbers than positive numbers. Is that right? Is that something could be people are thinking? Is that true? There are more real numbers than positive numbers. These questions sometimes can be even philosophical. As a matter of fact, there are infinite number of real numbers. There are infinite number of real positive numbers. You can't compare them. You can't compare them. They cannot be compared. But one thing we know, this function is one-to-one, is increasing, isn't it? It's increasing, therefore it's one-to-one, isn't it? So there are just as many real number as there are positive numbers. How many? I don't know. Nobody knows. Infinite. Infinite. If these are the things that puzzles you, all you have to do is look at what we have done. Okay, this is what we have done. Okay, input, output. Input cannot be negative, cannot be zero, but input can be any positive number because you can easily, there are infinite numbers between 0 and 1/8, right? And they will all produce output. Those output will be where? Those output will be here, getting lower and lower. Remember we pointed out yesterday? Yeah? As x getting closer and closer to 0, what happens to the output? The output is getting smaller and smaller, smaller, infinitely. Never ending. But the output can be negative. Even though the input are positive, the output can be negative. Can you accept that fact? You guys, yes. Can you accept that fact?
Yes.
A lot of our students cannot. They will say, oh, the domain is actually greater than 0, therefore the range is greater than 0 too. Do you guys see the problem? I often see those answers, those mistakes. Okay, that's why we plot the points. Okay, from the simple things you observe. You follow me? It's not hard to see. It's not hard to see. Now you agree with me, do you? Do you agree with me? It's not hard to see, yes?
Yeah.
So mathematics oftentimes is observing the simplest and draw the most remarkable conclusion. Observe the simplest and draw the most remarkable conclusion. Okay, and you can do it. You can totally do it. All right. So without further ado, let's continue. So I did point out something here on the aspect of limit, okay? This is the piece that a lot of our students, when they get to calculus class, they totally don't get it. By that time, the professor didn't have time to go over these details. Your professor will not have time to go over these details in calculus, okay? So I want to put it on the summary. And we put that down yesterday, right? So this is the limit aspect, right? The limit aspect. Limit at 0. Okay, this function is so important. So important. You not only need that in calculus 1, you also need that at calculus 2, guys. Limit at infinity. Okay, these are two things I want to point out. Limit at 0, what does that mean? As x approaching 0 from larger than 0, log base 2x approaches negative infinity. If the next one is easy, as x approaching positive infinity, log base 2 approaches positive infinity. Okay, these are kind of accessories. Okay, you know, I don't have to teach you this, but I just give you as like bonus. Okay, you need these bonus. So let's get to x-intercept, y-intercept. We touched these yesterday. So I expect answers from you. X-intercept, y-intercept.
The x should be 1, 0, and the y should be none.
That's right. Perfect. Any questions? Any questions? And what are we going to do next? I want you to bring 2 to the power x next to this table. Okay, do you guys have 2 to the summary of it for 2 to the power x? Let's find it. 2 to the power x, right? We have a 2 to the power x table, don't we? Do we? I'm going to bring it to the top. We're going to make some adjustment to these 2 tables. Okay. Oh, we're missing a graph. That's why one is taller, the other one is. That's right. How could I forget that? It must be sign of old age, right? Yay. Look at that. Look at that. Okay. So now, what I like to do is I'm going to make another column. Okay. I want you guys to make this table better organized. Okay. Let's make this table better organized. Okay, so I'm going to put another column here. So I'm going to make one table. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Wait. There. Something will not line up very well. Is that right? We compare the graph we compare the rule, right? And we also know they are inverse function to each other, don't we? Oh, we have that one sentence. Okay, that one sentence. So I'm going to just put this one sentence thing elsewhere. I'm going to put it here. How about that? I think that's what will be most relevant. Okay. Well, the one sentence, that one sentence statement is critical, right? Do you guys remember that by now? Huh? Very, very important. Very, very useful. Okay. And I will also give you the bonus for the limit. But before that, you put these two functions next to each other, right? They are inverse to each other, aren't they? They're inverse to each other, yes? And we have made a statement about the inverse function domain and range, right? One's domain is the other's range. Is that true? Domain, range. Domain, range. Do you see that? Do you see that?
Mm-hmm.
Okay. This one is a limit at 0. So I'm going to put it over here. Okay. And this one limit at infinity. For 2 to the power x, limit at infinity is also when x approaching infinity. Okay, this is pretty trivial. That this is when x approaching positive infinity. 2 to the power x approaching positive infinity. That's easy to see, isn't it? But there's a first one. I'm going to give you limit at a negative infinity. Okay, so when x approaching negative infinity, you guys are already learning calculus. Okay, 2 to the power of x is approaching what? Is approaching 0, larger than 0. Okay, which is this piece, right? Do you guys see the arrow I used? You guys see the arrow, right? As x approaching negative infinity, the height, right? 2 to the power x is getting lower and lower and lower. Does that sound familiar? But never touch x-axis, always a little bit above x-axis, but get close to x-axis as close as possible. That's what this sentence is describing. You follow me? That's what this is describing. You follow me? So these are the bonus. These 2 lines are the bonus for your calculus use. Any questions so far? Summary. Do you think you can do it? Did you do it yesterday? Do you think you got something similar to this? Yeah? Isn't that helpful to do summary often? Okay, so let's move forward. Let's move forward. Okay, so next, we're gonna do natural log, ln x. We're gonna do ln x. Okay. Before we do ln x, actually, I'm kind of debating if I should do this with you. Okay. I want to address this property. So summary on f and f inverse. So let me do it anyway, okay? Because even if you understand 80%, 90% of it, you can always come back to it. Okay? Now, remember that property we talked about earlier, which is the one-to-one function, right? The one-to-one function. We did that with 1 over x. So this time I'm going to do this again. So I'm going to write this notation. F of F inverse of x is equals to x for x in the domain of F inverse. Remember this? Yeah? Okay. Now, F inverse of F of x is equals to x for x in the domain of what? F. Okay, we're going to be doing this so many times. I'm hoping after we've done this so many times, you will be the master of it. So now we're repeating, right? Do you see we're repeating? And we know that this is only true if F is 1-to-1, right? In our current example, right? So this is a general statement. This is a general statement. Okay, I can say if F is 1-to-1, then, okay, and F inverse is its inverse. Then, okay, so this is a general statement. Then I would say, in particular, this is going to be true for these two. Okay, let's see how would that happen. Let's see how would that happen. How do we compose this? Right now we have to use a concrete function, right? We have to use a concrete function. So just to give you a little more, I give you a little more stuff, because we have talked about compositional function, right? We talk about compositional function. I just want to make it more complete. Okay, more complete. If you have any questions, please don't hesitate to ask me. Okay. So this thing we're going through, I mean, I tell you, it could be tough. It could be tough for some people, but you must learn this. You must learn this. Okay, now, so this is a general statement. Because this is general statement, and we have a 1-to-1 function 2 to the power x here, and its inverse is right here, right? I can put in, it doesn't matter which order, really. It doesn't matter which order. So now let's see how we verify this. We know this is going to be true, but how do we apply it, right? So now let's look at right? This is F inverse. Okay, this is F inverse. Okay. And this is F. All right. So we have a machine. I'm going to bring the machine back up. X as input. You will see this theme being repeated over and over again, guys. Okay. These will be repeated over and over again. Okay. So don't you worry that you only see this once, you never see this again. You will see it again and many more times. Okay. Domain range we have in the table, right? The next one is X as input and the inverse, and this is the scenario. Okay, I'm doing this because I will need to use it in a little while. Okay, so log base 2x. Okay, with all these said and done, now we're going to compose this guy. Do you have your paper pencil with you? Yes?
Yes.
How about we do some example first before we do the general form? Shall we? Shall we?
Okay.
You follow me?
Examples are good, yes.
So yeah, do you think it would be a good idea for Ruth? We do some example first, right?
Absolutely.
Yeah, let's do some numbers. Let's do some numbers, okay? So now I'm going to pick an X here because X is being acted on by F inverse. So this X must be from where? From the domain of F inverse, right? What's the domain of F inverse? Positive number, right? Positive number. So let's do some simple numbers first. I'm going to choose 1. How about that? Right? So X equals to 1. It's in the domain of F inverse, which is this guy. Okay. Now, what is F of inverse 1? So you see F of F inverse 1, right? So we're going to do the inside first, right? So F stays outside. The inside F inverse of 1. What is F inverse of 1? Well, this function machine is used, right? So when X equals to 1, give that to F inverse, what will happen? And it produces what? What does it produce? You basically plug in, right? You replace X by 1, right? What is log base 2 1?
I want to say 0.
Yes, absolutely. We plot this point, right?
Hmm?
Hello, everyone. Look at the table we plotted. Okay, look at the table we plotted, right? So this is going to be 0. Now, what is F of 0? For F of 0, we're going to use the other machine, right? And that's going to lead us to which function? The F machine. And the F machine is going to give you what? 2 to the power 0, isn't it? What's 2 to the power 0? Come on, guys. Is this too easy for you?
No, so I'm writing all this down. That's why.
That's right. 1. Yes. So the answer is what? 1. You see that for input 1 from domain of this guy. So after these 2 machines, you get 1 exactly. We're not proving it, okay? We're verifying it, okay? We're verifying it. So let me put the word verifying. This is not a proof, okay, guys? This is not proof. This is verifying. Okay, so here I'm going to put the word verifying. Verify. Okay, let's put it on the record. I never say this is the proof. This is not the proof. You follow me? So now I want you guys to try a couple. Are you ready? Are you ready? X equals to 2. and x equals to 4. We can have a breakout session if you wish. Okay, I want you guys to run the machine yourself. So this is going to be 2, and this is going to be 4. Well, I'm gonna open up the breakout session if you wish, or if only if you want to. Okay, with all these properties in front of you, maybe I can make the fonts. No, you have everything, right? You have everything, don't you? Anywhere you need to write it down? Yes? Okay, so now you're gonna run the machine for 2, 4, and then more to come. There are more to come, okay? All this to practice your exponential and logarithm skill. It will help you to do the homework. I promise you, I promise you. You guys follow me?
Professor, I copied those example on my board. If you create
Okay,
breakout room.
breakout session, breakout rooms. Let participants choose rooms. Okay, so let's run the machine. Let's go. Let's go. You can do it. I know you can do it. Okay, we are holding your hands. Okay, if you choose to be in my room, feel free to ask question. How are you guys doing? How's it going? So for 2, right? For 2, we will start with f of, right, the inverse function, which is log base 2 of 2, which will give us what f of log base 2 of 2 is 1, right? So that's going to be 2 to the power of 1, and that's equals to 2. Did you guys get something similar? Yeah. And the next one, you'll have f. So this 2 will plug in the inverse function, which will give us log base 2 of 4. Log base 2 of 4, that equals to 2. And f is 2 to the power x, so the 2 to the power 2. And that's going to equals to 4. So to summarize, right? We got that. And we got that. And we got the last one. Okay, I'm going to remove all the accessories. Okay, we remove all these accessories. Doesn't that verify all of these, right? If x is 1, this is 1. This x is 1, this is 1. If x is 2, this is 2, right? 2, 2, 4, 4. All right, and I'm going to close the rooms. Any questions so far, you guys? Come back. Right? So I'm going to give you 2 more examples. All right. How are we doing? Oh, wow. Time is up. We don't have time to do ln x today, but we did a good session on 2. We did it, I hope we did it very thoroughly. Okay, if we did it very thoroughly for base 2, and then when we do natural log ln, it's gonna be super duper amazing. It's gonna be super duper amazing. Thank you did you have enough time to do it?
Yes, ma'am. Thank you, Professor. Yes, we finished it on time.
Wonderful. Shall we compare notes?
Yes.
For x equals to 2, right? F inverse of 2, you plug in this one. So you have log base 2 of 2, and log base 2 of 2 is 1. So f of 1, and that equals to 2 to the power 1, and that equals to 2. For x equals to 4, right? And 4 is plugged in this function, and you get log base 2 of 4. Log base 2 of 4 is 2, and 2 squared is 4, because f function is 2 to the power x. May I give you 2 more? All right. Okay. We're running out of time, so I hope we can do this a little faster. So I'm going to give you 2 more. Okay. One is x equals to half. And the other one, sorry, these together, okay? X equals to half. And the other one is X equals to quarter. Okay, we continue to verify, just for the fun of it, okay, with these two. So one is for half, and the other one is for a quarter. Can you guys just do it here so we can finish, because we have another half to verify. You follow me? Okay. You have 2 minutes. 2 minutes. Continue to verify. Okay, so these are our functions. Our function and its inverse.
I found the first one, but I don't know if it's correct.
What did you get?
So for f of -1, I did log base 2 of 1/2, which equals to -1, and then I put -1 for the regular f, which just gives me -2.
Yeah. But may I correct you how to read it, right? It's called f inverse. Okay, this symbol I highlighted is read as f inverse. F inverse of half. So the input is always follows of. You follow me?
Yeah.
F inverse of half. That's how you read it. You are absolutely right. So this is a log base 2 of what? So you, for f inverse over here, you just substitute x by half. So this input is half. Okay, you can also go with the machine. Okay, you can also go with the machine. Okay, and f of log base 2 of half. What's the log base 2 of half?
-1.
-1. That's right. And then we use this other function, 2 to the power of -1. And 2 to the power of -1 is what? Half. Does it verify? Does it verify?
Yes.
Okay. So for quarter, you do the same thing. Right? You guys follow me? So this is going to be a quarter. And that equals to f of what?
-2.
-2. And that equals 2 to the power of what? -2. And that equals what? Quarter. Okay, guys, we have 3 minutes left. I might even have the tendency to take a little bit more of your time because we want to verify the other half. Okay, in the whole process. Okay. Verify this guy. Verify this guy. Okay, you can draw the machine. We've drawn the machine many times. Okay, because for the what we do here is that we're going to verify. So we're going to choose numbers from the domain of f. What's the domain of f? F is 2 to the power x, right? Domain of f, it can be it's all real numbers, right? 2 to the power x domain is all real numbers. So what I'm going to do is I'm going to give you at value x equals to -2, x equals to -1, x equals to 0, and x equals to 1, and x equals to 2. Okay, let's see if we can get this done in 5 minutes. I'm going to take you a couple of your time. I'm going to take some time from you. Okay. If you have to leave, it's fine. Go ahead. Okay. So do you already know what to do? We don't have time to do the breakout rooms, but feel free to use Farouz's office hour or my office hour right after this, okay? But let me keep this, let me have this recorded, and if you guys could stay, that would be great. Now, for input, okay, this input is going to be from the domain of what? In this case is what? 2 to the power x. Oh, what an ugly typing. 2 to the power x. Okay, so for f, okay, f inverse, of course. It's inverse. So for input equals to 2, okay, let me bring this on the same line. F inverse, so we're composing functions, right? F of 2 to the power -2, the function f is 2 to the power x, so -2 is plugged in here. So we get 2 to the power of -2. 2 to the power -2 is 1/4, isn't it? So this is 1/4. And you can keep it like that. You don't have to, right? And then this number, because this input, it will be plugged in here. So you're going to end up with log base 2 of 2 to the power -2. -2. And the answer is -2. Do you guys see that? The next one. So I have f inverse of f of -1. Okay, f of -1. You put a -1 in this place because that's the f rule. So this is going to be 2 to the power -1. Okay, and then 2 to the power -1 is the input for f inverse. So you're going to end up with log base 2 to the power -1. And that answer is -1. For 0, sorry, wrong thing. Okay, for 0, you have f inverse. We take the inside most first. F of 0, that's going to be 2 to the power 0, right? Because this is f of 0. You put in the rule for f of 0. So this is going to be 0. So f of 0, 2 to the power 0. And 2 to the power 0, of course, is going to be the input for the next one. And that's going to give you log base 2 to the power 0. I just didn't bother to make it 1, but it doesn't make any difference. You can make it 1 if you want. This is going to be 0. Last 2. Okay, last 2. I try to fit this on one screen, you know, that's what I'm trying to do. I'm trying to fit them on one screen, okay? So next, over here, right, for x equals to 1, we do the inside most first, and that's 2 to the power of 1, because x will be replaced by 1. So f inverse of 2 to the power of 1. And that equals what? We're gonna put in the logarithm, log base 2, 2 to the power 1. And that equals 1. Last one today. Okay, 2. F inverse of f of 2, which is 2, 2. So that's 2 squared, 2 squared. And then I take a 2 squared, I plug right in to the logarithm base 2. So I get 2 to the power 2 as the input. The output is 2. So far, so good, everybody. So we have just verified. Okay, we're verifying. We know these are true. We just want to see some examples. Okay, this is not a proof. So please, these are not proof. It's just verifying, or just give some examples. Okay, verifying examples. So all of these confirms what?
Confirm they are one-to-one function, Professor.
They are one-to-one function, and they have that nice, interesting property for one-to-one function only.
So your quiz question might be like 2 functions are given and you are asking us verify if they are inverse of each other or one-to-one function, something like that.
Absolutely,
Thank you.
absolutely. You should expect something like that, right? Should you? Yeah,
Yes, yes.
you expect it, right? You should expect it. Right? So the first one, we verified both properties. Tomorrow, we do the proof. Okay, we'll do proof tomorrow. It's going to be more fun.
And more
Okay.
practice,
That's right. Are you getting better? Everybody. I know you are. You are getting better.
As Professor mentioned, my hours today, Math Study Center 3 to 6 p.m. Office hours, Professor, just now probably, yes?
Yes, my office hours right now, so I'm going to have to turn this off and stop the recording, and I'll see you guys in the office. Please feel free to come.
Do you have any questions?